So this is S4 still. This is video number 3. So video number 3 on this topic. And this is confidence intervals. It's better that you do the practice problems for the first 2 videos before you do the confidence intervals, because the confidence intervals is a little more, it's kind of based on video number 2 as well, but it's a little more complicated, and it would help if you understood the other part of S4 before using this. So the idea of what we're doing is we're trying to find out, it's kind of cool, you can look, since you guys are at home, you can look up confidence intervals, and you could look up their kind of their overall meaning in a statistics setting. One example that I was reading about on Wikipedia is it says a confidence interval is like when you're doing a presidential election. So say that there's 40% of respondents intending to vote for a certain person. What a 95% confidence interval means is that you have, say, between, you say 40%, but then you say plus or minus 4. So what the 40 plus or minus 4 would be. So let me just write that. So this is just kind of some basic theory. So say you have 40% plus or minus 4%. So you're basically saying I could be 4% wrong. Okay, so I might be wrong. I think it's 40%, but I'm not exactly sure. So the 40 plus 4% would be 44%. So 44% would vote for a certain candidate. And then 40 minus 4 would be 36% vote for a certain candidate. So what a 95% confidence interval means is I'm 95% confident. This is called a 94% confidence interval. I'm basically 95% confident that the real the voting percentage would be between 36 and 44%. I mean, I'm not exactly sure that it's going to be perfectly 44%, but if I say plus or minus 4%, then that's basically like the margin of error, and you're saying, well, I'm not going to be perfect, but I'm 95%, it's going to be within this. So you can also go up to 99%, more percents, based on how wide you want your interval. So it's kind of interesting, and it's called a confidence interval. I'm going to show you how to mathematically find it. And this is not used really in IB or in AP Calculus, but it is used in AP Stats and in stats that you would take in college. So it's still valuable information, and so we still want to teach it to you. Okay, so how we're going to get this. So that's the theory, just a little bit of the theory. So let me show you what they give us for the problems. Okay, what it says. So let me give you an example first. Let me just teach you through an example. So this is going to be example 1. Okay, so what it says is it says the middle 85% of your data, and this is trying to get you used to confidence intervals. Middle 85% of your data is between A and B. And then it gives you mu equals 30, and it gives you sigma equals 8, and it gives you n equals 25. So n is a new letter that we haven't seen before. That's basically how many people you ask. So we talked about this a little bit in video 2 at the end when I was giving you a preview, and you're basically saying, hey, I'm going to only ask 25 people or look at data for 25 people, and then I want to use that data to make a decision about the whole population. So that's what they do in statistics. But for us, we're just going to find the confidence interval. We're going to find the A and the B, and we're going to just see how it works mathematically. Okay, and well, then the theory will be up to learning in stats, in a real stats class. Okay, so here you have your normal distribution. And I want the middle 85% of my data to be between A and B. So A and B are going to be X values. And you can call them capital A and capital B. This one happens to have them lowercase already. Okay. So I want 85% to be in the middle. And remember, the area is the probability or the proportion. So I've got 85% in the middle, and I want to calculate A and B. So it's very much what we did in the previous problems. The only difference between these problems is this n is new. Okay, and that's because we're using a sample instead of a population. And then we're trying to base our estimates and make that decision based on populations. Okay. But you do not have to know the theory for the problems that we're doing in class. We're just trying to practice the mechanics of it, the math mechanics of it. Okay, so remember we're going to use this formula instead. It looks like this formula. Okay, so it looks like this formula. This is the formula if there's no n. So if no n is given, which means we're dealing with a population. And then this formula is going to be x minus. Now we're going to call it mu, but in real statistics, it's x bar. Okay, but x bar is the mean, same as mu, but x bar is related to a sample and not a population, not something that you have to know right now. So this is sigma divided by the square root of n. So we talked about that in video number 2, but we didn't use it. So we're going to do the same idea that we did yesterday, where we have to find ZA and ZB in the other video number 2. So we still have to do that so that we can find A and B. Okay, what we're going to do is we're going to calculate what this percent is out here. Now, if you try to think of what the whole percentage is, the whole percentage of the whole thing under the curve, remember if you go all the way under the curve, so absolutely everything, that's the whole probability. So the whole probability would be 100%. So if I want this space at the edges, you have to think of what you want here. I guess it's a little, there we go. So what would you do for that? Okay, so I'm thinking 100% minus 85% is both edges, but they're equal because I want the middle 85%. So I want the A and the B to be equally spaced from the mean. So that's 15%, but that's 15% for both gaps. So this red area and this red area both have to add to be 15. So we're going to make this 15% divided by 2. And then this one's also going to be 15% divided by 2. Okay, but what would that be? That would be what, 7.5%? So that's 0.075. And this one's also 0.075. Now, how did we go backwards from area? So basically, we're going to have 2 sections here. So 2 sections. One is I know that the probability that x is less than a is 0.075. And then remember that in order to use the notation better, it's nice if we can do the less than on both of them. So instead of using 0.75, I'm going to shade it in blue. Okay, so I'm going to shade this less than b in blue. So I would need this whole area in blue. So there's a couple different ways I could do that. I could say the whole area minus 7.5%, right? So 7.5% is the only thing I'm missing. So I could do 100% minus 7, so that would be 1 minus 0.075, or I could do 0.85 plus 0.075. Both would give me the blue area. So if that doesn't make sense, pause it and look again. So I've got the 85% in the middle, and then the left section, it's called the left tail. The left tail is 0.075. So if I add that up, that's the whole blue shaded region. Or I could take the whole shaded region under the entire curve, which is 100%, or 1, and then subtract the 85, subtract the this red part right here. I'll highlight it in yellow. So I could subtract 1 minus this yellow, which is 0.075, and that would be the rest. Okay, so that is the area in both of these cases. So that's 0.99. It's interesting. So I don't know, I can't subtract. Okay, so that's 7.5. So I was thinking 92.5%. But is that right? Let's see. Let's see if that's correct. I'm thinking, so strange. I can usually do better calculations in my head here. Okay, so let's see. Yeah, 0.29. Okay, just being a dork. Okay, so this we go. So that's the probability that x is less than b. Okay, now remember how we do the less thans from yesterday. Now, one of the less thans I just did on my own. I did not use the calculator. I just used information I did before, but somebody was confused, and so they sent an email, which is great, to another one of the teachers to say, where did this number come from? So I just want to be real clear. So this is ZA is inverse normal of 0.075. And this ZB is the inverse normal of 0.925. And then let me write right here what I would do on the calculator. Okay, I'll write it in blue, just so you know this isn't the normal work that you show. But I think it's important, especially since you're online, to be able to figure it out. Now you do inverse normal, and you do inverse normal of the area to the left, and then you need to give it 0 and 1 for your mu and your sigma, because I'm looking for a z-score. Okay, so this is going to be ZA. This is how I'm going to figure it out. Now, inverse normal is on the distributions menu. Okay, so distribution menu on the calculator. I think it's DISTR. And you're going to pick inverse normal. Okay, so I'll go there right now. Usually I do all the calculator work at the end. I'll go there right after I write this one. So this calculator will be ZB. And this will also be, on the calculator, inverse normal. And I'm going to give it 0.925, comma 0, comma 1. Okay, so that's my plan. Same thing, inverse normal is on the distribution menu on my graphing calculator. So I'm going to do that right now. So 0.075 and 0.925. So I'm going to go here, and I'm going to go back. I'm going to go over to the calculator. So I'm going to go to my app. That's my calculator. Okay. And we said that we want to do inverse normal. Now, where's inverse normal? So see the DISTR button? You know what? I was thinking that maybe you couldn't see yesterday where I was pressing. So let me take a picture. Let me take a picture and circle it. Okay, so see this button right here, the DISTR button? So I'm going to have to hit second, and then I'm going to have to hit that. Okay, so this is just a screenshot, so you won't see the screenshot, but at least you can see it in the video here. So DISTR, so I'm going to have to hit the second button. Okay, so I'm going to hit second. I just hit the second button, and then I hit DISTR. And then number 3 is inverse normal. Now I need inverse normal of 0.925. Well, let me do the first one first. So that's 0.075. Mu was 0, and sigma is 1. And then I'm going to hit paste. Now paste makes it look like what I had written in blue on the other page. So I'm going to write that. Now that's negative because it's to the left. Okay, ZA in the picture is to the left of the mean. And that's why the z-score, remember inverse normal gives you a z-score. So a z-score is a standard deviation, which is left. So I'm going to hit store. So the store button, let's see if I can do this with my pen. Okay, so the store button is right here. Okay, so I'm going to hit store, and then I'm going to store it as A, even though it's ZA. Okay, so I'm going to store it, and then to use the A, it's green, so I'm going to have to hit the alpha button. Okay. Okay, so that's what I'm going to hit. So I'm going to hit the store button, and then I'm going to hit the alpha button, and then I'm going to hit the A button so I can store it as A. Now later I'm going to need to use this, and I'll go back to the calculator. It'll still be there. Now I have to do inverse normal again. Now it's up to you. You can hit entry, second, and the word entry, which is over by the, on the enter button. I can hit second entry, or I can just redo it again. So let's do second distribute, inverse normal, and this time I want 0.925. Oops, too many decimals. 0.92501. So I'll let you catch up. Okay, you can always pause. And then that would be the answer here. Now that's positive, and it's actually the same number. So I'm going to hit the store button, and then I'm going to hit B. Now the reason they're the same number is if you look at your picture, if you look at your Z number line, they're an equal distance away from 0. So since they're an equal distance away from the middle, that's why they turned out to be the same number, but one's positive and one's negative. Okay, so let me go back to the other screen. Okay, so I'm going to go back. I'm going to go back to my OneNote. Okay, so that's how I found the ZA and the ZB. Let's flip back to sideways. Okay, so that's how I found those. And then I stored them. Okay, so that's how I found the ZA and the ZB. Now I'm going to do the same thing to find A and B as I did before. So similar thing, not exactly the same. But remember, I have to use this new formula. So let me highlight that new formula for you in yellow. So I'm going to have to use this formula because I was given an n value. Okay, so I'll zoom down so I can see that. Okay, so this one, I'm going to write Z equals x minus mu over sigma divided by the square root of n. I'm going to write it in both sections because I'm using it in both sections. And then that mu is, remember, in AP Stats, they're going to give you a different name for it. It's called x bar, and it looks like this. It looks like x, and it has a little line on top. It also means average. It's like if you're averaging 25 numbers, rather than you're looking for every, like say you wanted to average 25 people's SAT scores, versus a population is if I want to know all of the SAT scores. So that's what x bar is versus mu. But we're not going to use x bar. In our class, we're just going to use mu. Okay, so let's take a look. So the data is up there. So Z is ZA, which I stored on my calculator. X is lowercase a, minus mu, which they said is 30. Sigma, they said is 8, divided by the square root of 25. Okay, so to do that, I'm going to do ZA equals a minus 30 over 8/5. Now what's strange at this step is this fraction here in the denominator makes you feel like flipping it. Now if you flip it, that's legal, but that means you'd have to flip it on the right side of the fraction, on the right side of the equation. But actually what I want to do, I don't want to flip it. I want to cross multiply it. So I am not flipping the 8/5. But it's very common for students to flip the 8/5. So 8/5 ZA equals a minus 30. And then how do you find A? Let's add 30. So 30 plus 8/5 ZA. Now ZA is in my calculator. So I'm going to go back and I'm going to find that. And then I'll calculate that number. So this is going to be my A value. Okay, and then my B value, I do the same thing. So ZB, which I have stored. Remember that was the positive version on the calculator. X is B on my X number line. I'll zoom down so you could see that. It's right between the blue region and the yellow region. Minus mu. Mu was 30. Sigma is 8. And the square root of n is square root of 25. Okay, now you can't learn math by watching, so you're going to have to make sure you're writing this down. So you want to be watching, you want to be listening, you want to be writing it down in your notebook. And then that's going to help you the most. 8/5 ZB, you're doing the same plan. So you're going to cross multiply, and you're going to get 8/5 ZB equals B minus 30. Then you're going to add 30, so 30 plus 8/5 ZB, which turns out to be the same thing. Okay, not the same thing, not the same answer. But okay, and then you're going to find your A and your B. And then your answer is basically going to be something like this. You're saying that the real value, okay, so the real, like say the real voting percentage is between A and B. So 85%, the middle 85% is between A and B, but I have to figure out what they are. So I'm going to go back to the calculator again. You know what I think? I think there's a way that I could do a split screen. I think I can do a split screen. Let's see if it lets me do a split screen. I don't know. Let's see. I think I can do a split screen. Look at that. Oh, this is cool. Does it let me do a split screen here? Okay, I don't know how this is going to work. We'll see. We'll see if this works in the video. This is a test. Let's see. Oh, this is kind of cool. So we'll see. Hold on. Clear. Can I hit the clear button? Oh, it doesn't really line it up properly. Clear. Okay. So that doesn't really help. I'm hitting the imaginary clear button over there. So I'm hitting the down arrow. Yeah, I know. So that's not going to work. That was kind of exciting, but it's not going to work. So let me double click on this one. Wait. How do I get rid of this? Let's see. Hold on. I'm going to pause. We're having technical difficulties. Let me double screen this. So pause. Okay, let's see. Okay, I figured it out. Okay, so we're not going to do the double screen thing, but I can still go back to the calculator. So the calculator, I need 30 plus 8/5 of z. Okay, so let's go to here. Oh, that's interesting. It still saved my screen. There we go. Okay, so there we go on this one. So what I'm hitting is I'm hitting clear. I probably shouldn't have hit clear because we could have left all that stuff on the calculator. But remember, I stored it. So I'm going to type in 30 plus 8/5 times ZA. But what did I store ZA as? I stored it as alpha A. Okay, so I hit the green button on my calculator, and then I hit the A. Enter. Okay, so that is little a. And then little b would be 8/5 times ZB, which I called B. So those are my numbers. I should write those on a piece of paper. So you have a pen. Okay, I'm going to pause again. Okay, so this is the calculator. I wrote down those numbers. So let's go back to my other screen. Okay, so I'm going to go back to my other screen, my OneNote, and then I can write those numbers down. Okay, so these numbers right here, let me flip back to sideways so you can see it better. And then A was 27.697 approximately, and B was 32.303. So what we're saying, basically, is that we know the real mean of our population is somewhere between here and, that's basically what we're saying. But right now we're just trying to find A and B. So it doesn't specifically say in this problem to find a confidence interval. It just says it wants the middle 85% of your data to be between those values. Okay, so we drew a picture and then we calculated A and B. But this is an actual confidence interval that we could also have done. Now, there is a way to check. No, because of the N. Yeah, no. Okay, so let's do another example. Okay, so let's see. Did I call that one example 1? Okay, so this is example 2 of this video. So example 2 of this video does say find a confidence interval. Okay, now it gives us a different letter. It gives us alpha. Okay, so alpha is 0.05. Okay. And then it says find a confidence interval. And it gives us mu equals 50. It gives us sigma equals 4. It gives us n equals 16. So 16 objects that we're trying to, that we looked at the average of, and that's what gave us 50. And then we want to see what the true mean is. So we look at this. Now this 0.05% is not the confidence level. Okay, so there's two numbers. There's alpha, and then there's also the middle percentage. Okay, so the 0.05 is like 5%. So that 5%, when they say that as an alpha value, that 5% is the amount that's in the two tails. So that's the amount that's in the red, the yellow, and then the other yellow. So that total is 5%. So then the confidence interval, or the confidence, how confident are you, what the confidence percentage is the other from 100. So 1 minus alpha, which is 0.95, which would be a 95% confidence interval. So I believe the alpha is called the confidence level, and this is called the confidence, I'm 95% confident. So 95% confidence interval. Okay, but you're going to learn a lot more about this in college statistics or in AP stats if that's what you decide to take. Okay, so the 0.05 is over here in the yellows. So if the 0.5 is in the yellows, how am I going to get each yellow? So I'm going to write that in red. So this is 0.05, but that's not really 0.05 because it's both yellow. So you're going to have to divide it by 2. So 0.05 divided by 2, which is 0.025. This is 0.025. Okay, I probably shouldn't write those down there because that's usually where my x-axis is, so let me still stay consistent. There's my x-axis, there's my z-axis. So this number right here is 0.025, and then this number right here is 0.025. Okay, now the confidence interval is still the A and the B. I usually like to use capitals if it doesn't give me the letters as lower cases. So I have the capitals, I still have my ZA, which is the z-score for A and the z-score for B, so the plan is the same. Technically, this 95% here, or this 95% here, is 95% is here in the middle. So if you knew the blue, subtract from 100%, divide by 2, that's how you get what's in both of the tails. Okay, so now I'm going to write it as my probabilities, and I'm going to write 2 of them because I need to find A and I need to find B separately. So the probability that X is less than A equals, so how much area do you have to the left of A? And that's 0.025. And then what's the probability that S? Hey, puppy. Okay, so let's finish this problem. I keep having technical difficulties. I keep hitting the button and then it cancels. So I'm going to have to splice these videos together. Okay, so this one, probability that X is less than B, is what is the area to the left of B? So let me highlight B for you. So what is the area to the left of B? So try to figure that out yourself. Okay, so I'm going to color that in blue. That one side that looks like it's green is still in my blue area, right? Because blue plus the yellow made green. Okay, so basically it's the 95% plus, I can do 95% plus that 0.025. Okay, so those are the two numbers. I can do the 0.95% and the 0.025. Or I could do 1 minus the 0.025 that's right over here. Okay, so you can do it either way. Either way, you get the same answer. So this is 0.975. Probability X is less than B. Okay, now we're going to find the z-score for A. So the z-score for A is the inverse normal of 0.025. Inverse normal looks like that. You type in inverse normal in your calculator. Inverse normal. You put 0.025 for the area, you put 0 for the mean, you put 1 for the standard deviation. And that is ZA. Technically, that's calculator. So this part right here is calculator notation. So you wouldn't have to write that on the paper, but it's kind of nice for math analysis teachers to see it so we could see what the heck you're doing. Definitely write that on your paper for notes. Okay, inverse normal, 0.975, comma 0, comma 1. And then this will give us, again, this is on the calculator, so technically it's invisible if you were doing this in college. But you can still write it. I don't think any professor would get mad at you, but you want to also use the proper notation. Oh, I forgot a notation over here. So on this one, I forgot to say that ZB was the inverse normal of 0.975. So technically these two steps should be switched. So I find those on my calculator. And then I like to do the rest, and I like to type it into my calculator later. So z equals x minus mu, that's the same. And I look and I say, do I have an n? So up here I do have an n that I just colored in yellow at the very top over here. So n is 16. So when I do my thing, instead of doing sigma, I use sigma over the square root of n. So I'm going to do that same thing here, x minus mu over sigma divided by the square root of n. If there's no n in the problem, then this is not the formula you use. You just use the over sigma formula that we were using on the other videos. Okay, so z is ZA, x is A, and mu is given 50, and sigma is 4 divided by the square root of 16. So ZA equals A minus 50 over 4 over 4. Oh, that's interesting. So that's just 1. Well, that's kind of boring. So that's A minus 50 over 1. I guess I don't even need to cross multiply. So that would be A equals 50 plus 1 ZA, but you wouldn't really have to put the 1. And then this should work the same way, ZB. So you're just getting used to this. Make sure you practice the question, see where you get stuck. You can ask your teacher. You can send a message to your teacher. You can send a message. I don't know if you can post a comment on the YouTube video. You probably could. You could ask me a question, tell me what minute it's on, and then I'll try to answer you. Or you can send it to your teacher directly. Your teachers all know this information, and they're very happy to help you. Okay, so square root of 16. So that's B minus 50. Again, over 1, because that's 4 over 4. So that's B equals 50 plus ZB. Okay, and then I'll show you how to do this on the calculator, just to make sure. I have my other one, and then I do have my pen, so I'm going to write down the answer so I don't have to have the technical problems that I keep having. So let's see. Okay, so let me go to the calculator. We're doing inverse normal of 0.025 and inverse normal of 0.975. And then I will need to do 50 plus 1 ZA, and I will need to do 50 plus 1 ZB. Okay, so let's see. Let me go over to the calculator. My calculator, WapidEmu. That's free for any of you Android users. You can download it. Okay, so let's see. For this one, this is inverse normal. So I'm heading second distribution. I go to inverse normal. It asks me for the area to the left. So that's 0.025. Now, some of you have a calculator where it's going to ask you left, right, or center. So just use left. Okay, so left is the standard. Okay, so I'm writing that number down. So that's negative 1.95996 ... But right now I'm already ready, so I might as well just multiply it by 1 and then add 50, which is what we said. We said 50 plus 1 ZA. So this would be 48.040. And then inverse normal. So distribution, I go to inverse normal. I want to do 0.975. And the same things, I put that in. And then I multiply that by, I don't even have to store it if I do this, right? So times 1 plus 50 is B. So that's 51.95996 ... But I'm going to round that to 3 decimal places. So I'm going to round that to 51. And then let me show you how this works. I think you guys already know how to round, but just to make sure, it's kind of cool. Okay, so this number right here, the 9, I'm going to have to round because we want 3 decimal places. So let me make that a little clearer for you. So here, let me get, where's my pen? Okay, so right here, this 9, I want to decide keep or stay, or keep or make it go up 1. Well, this 9 after it makes it go up 1. Okay, but if this number here, this 9, makes the 9 next to it go up 1, the problem is, how do you go up 1 from 9? So you do 10. So let me write that in red. I'll maybe make it a little skinnier. Okay, so that makes this 9 a 0. And then carry the 1, because it really makes it a 10. So that's actually 0.9. Instead of 59, it makes it 0.960. Okay, and you do need this 0, because that 0 there indicates that you are rounding to the 3rd decimal place. If you don't put the 0, it appears that you only rounded to 2 decimal places. Okay, so on the other paper, we're going to write 51.960 as our rounded answer for our B. Okay, so that's it. And then let's go back to the other screen. I'll get faster, you guys. So if you're like, hey, these videos are taking too long. Okay, I'm just getting used to it. And more careful explanations is better, right? You can always listen to me at 1.5 or 2 if I'm going too slow for you, and then you can hit pause. I'm not sure if stats is the time to do that, but it's definitely possible. Okay, so B, the second one was the 51.960, and the A was approximately 48.040. And so X is between 48.040 and 51.960. So this is the confidence interval. Sometimes we call it CI, but I usually just call it a confidence interval. Now, what kind of confidence interval this is this? It was what? The confidence level was 0.05. So the confidence interval, it's called a 95% confidence interval, or alpha equals 0.05. Okay, I believe that's called confidence level, but I'm not 100% sure. Okay, so let's do, we're going to do one more example, and then I'm going to splice these together. Okay, so we're going to just do one more example. This one's more written in word form. So let's see. So this one, I'll try to do this one a little faster. So what example are we on? Are we on example 3? Yeah, example 3. Okay, so example 3, we have mu equals 30, sigma equals 8, 96% confidence interval. And they say sample size. So that's like how many people you're asking what their opinion on voting would be. Sample size of 100. Okay, so same idea. Make our little thingy here. We need 96% to be in the middle. Equal on both sides. This is X, this is Z, this is ZA, this is ZB. This is A, this is B. We're looking for the answer to our question to be between A and B. So the confidence interval is between A and B, so my job is to find A and B. Because I'm given the area, I have to go backwards. These, you might want to pause it and try it yourself, and then you could check it with my answer. So this is 0.04 divided by 2. I got that because I was thinking 96%. What's left from 100, that's 4%. But that 4% is for this section and for this section. So each of them is 0.02. 0.02. And then they add up to be 1 altogether. So this area is 0.02. This area is 0.02. So same thing as before. Okay, so same thing as before. We have the probability that X is less than A is 0.02. That would mean ZA is the inverse normal. So the Z-score, that's how many standard deviations away you are. So this is area to the left. So check your inequality sign. Do you have the area to the left? That's the only time you could use this inverse notation. So this is 0.02. On my old calculators, that's all I had to type in. But on yours, it asks for what? Area, and then it asks for the mean, and then it asks for the standard deviation. And I'm using 0 and 1 because I'm talking about a Z-score. Okay, so from there, we do what? Z equals X minus mu over sigma. But what's wrong with that formula? What's this? So what's 100? So 100 is your N. So that means I do need an N in the formula. If I have an N in the problem, I need the N in the formula. The theory behind that, you could watch on YouTube if you wanted. You could see what happens with sample sizes and confidence intervals if you want. Oops, that's not what we need to do. Okay, so I'm substituting. X is A minus mu. Mu is, they gave it to us, 30 over 8 divided by the square root of N. N was 100. So this is A minus 30 over 8/10 equals ZA. And then you multiply by 8/10 because you're cross multiplying, not multiplying by the reciprocal. And then UA equals 30 plus 0.8 times Z. That's what, ZA. Okay, and we know what we're going to get over here, but let's keep going. Let's write it the way we want to write it so that we can get used to it. You don't have too many homework problems. The total is 18, but really Z4 is like 2 days. Z4 has really 2 big concepts in it, which is confidence intervals and then also cutoff values, and that's what we did before. And you already practiced those questions, hopefully. Okay, so what is the area to the left? Now, although our calculators do to the right and center, we want to practice to the left so we could use our notation. So this is 0.98. How I got that was I was thinking 1 minus the 0.02. Or you could do 0.96 plus 0.02. That's your choice. ZB, which is the z-score for the B, would be inverse normal. So I'm going to use inverse normal on this, 0.98, comma 0. Oops, that's funny. Okay, so let me do a little correction here. So see this right here? I'm like half in calculator notation, and then I'm half in inverse normal notation. Okay, so this, you don't write this in the this inverse normal notation unless you're using a calculator. So there we go. So that's the end. So that's the actual notation. And then remember that to type this into the calculator, you do inverse normal. And that's when you put the 0.98, comma 0, comma 1. Okay, the notation, this notation that I'm highlighting right here in yellow, that notation requires that you write the area to the left. Okay. The calculator is very flexible. It's very cool. It helps you in stats in college, and it helps you in AP stats. So you have a lot more flexibility, but we want to make sure that we know the math behind it. Okay, so X. So X is our B, capital B, minus our mu. So look up your mu. Mu was 30. And sigma was 8, N was 100. Okay, so that's ZA equals B minus 30. You kind of feel like you're doing the same thing twice. 8/10, cross multiply. And you get 8/10 times ZA equals B minus 30. B equals 30 plus 8/10 of ZA. So you can type that into the calculator. I'm going to write that on my little paper here. So 30 plus 0.8 ZA. And we have 30 plus 0.8 ZB. Oops. Over here, lucky I wrote that down. I made a mistake. So I'm going to write this in red. That's supposed to be a ZB, not a ZA. Otherwise, we'd have the same answer. Okay, and then I'm going to do an inverse normal of 0.02 and then an inverse normal of 0.98 when I go to my calculator screen. And then once I get that answer, I'm going to have my approximate A, I'm going to have my approximate B, and then I write my answer like this, and then this is going to be my final answer. So let's see. And this is our last question for S4. Let's see. Calculator. So my calculator is right here. Okay. Second distribution. So you remember where it is. Inverse normal. The area was 0.02. Area to the left. Mu is 0.1. Paste. So that z-score, which sometimes people write down, and in fact some people in stats round it, and then later they use that rounded answer. But in math classes, especially in math analysis honors, we're not supposed to use rounded answers for future parts of questions. So I'm just going to keep that part in the calculator. I'm going to type times 0.8, and then I'm going to add 30. And I get for A, 28.357. That was a nice one to round. And then we do the same thing again. Distribution, inverse normal, 0.98 instead. Mu is, that's it. So that is the z-score. It's the same number. Notice that's the same number as the inverse normal we did for 0.02 because they're an equal symmetry around the mean. And then I want to multiply that one by 0.8 or 8/10, and then I want to add it to 30. And so that one turns out to be 31.629. So that takes the 2 and rounds it to a 3, which is kind of a normal one. So that's it. Remember, you can pause my video at any time you want. You can also watch it on super speed. Also, if it's blurry, hopefully all these videos haven't been blurry, but they're recorded in 720. So you can hit the settings button, and then you could change it if you want. And that's all. Okay, so let's go back. Here we go to OneNote. Flip it around. Let's write down my answers from the other page, which is 31.643 and 28.357. So the idea is I am 96% confident that the real mean will be between these values. So if this were voting, the candidate would lose because we don't know exactly what people will vote, but we know that the person's only getting between 28.357% of the vote and 31.643 of the vote. So that one would be very good. Stats is an amazing thing. You very possibly will have to take it in college. It depends on your major. It's kind of neat, but this is the stats versus the probability. So the P's were the probability, and these are the stats. So the stats are kind of neat, and they apply to all sorts of word problems. They're pretty exciting. You could, during this break, if you're bored and you want to, some of your friends in AP Stats, you could kind of ask them what they're doing. And there's some stuff on Khan Academy that you could learn. But try to stay on our schedule. But if you want to learn extra, it never hurts. Never hurts to learn extra, depending on how bored you are. Get some rest and be safe.